Hi guys, as you all know that my channel is mainly built on these 3018 CNC machines. I almost cannot get away from them. I have to say that this type of machine is great for learning, experimenting and prototyping. They are affordable, easy to use with many freeware, but after a while you surely will want to move on to the next level. Such as this machine. I showed you before how I built this CNC machine using a 3018 CNC. This machine here surely can be the dream machine for many hobbyists, especially viewers on my channel. I have been using it very intensively to make many things. It is still working perfectly as it should. It is sturdy, precise, fast. It can cut aluminum very easily without any problem. The only thing that is still bugging me is that this machine cannot mill steel, mainly because of this high-speed spindle. The maximum speed is 24,000 RPM and that is way too fast for steel. The milling bit will get burnt and ground away. You probably will ask, why don't I just cut at lower speed? The problem with this type of spindle is the torque will reduce with the speed. Lower speed means lower cutting power. And also, as being pointed out by many viewers, this machine design, moving gantry, is not the best for metal cutting. Today I decided to build a new CNC machine that will solve both of the problems that I mentioned, so I can finally sleep through the night. Of course, using this machine to build a new machine is not much of a challenge for me, but it will be for many people since they don't own this machine. To make the task more difficult, I will use this 3018 CNC to do it. This version of 3018 CNC can mill aluminum slowly, but I don't want to spend a month to make all the parts. To have the new machine faster, I will make the brackets using plywood first, which also will allow anyone with any version of 3018 CNC to do the same thing. Once the first version of the new machine is built, I will use it to upgrade the brackets to aluminum. That probably will be enough for this video. The final step is to upgrade the spindle to a high torque, low speed type, and that will be in another video. Now let me show you how my new machine will look like on the computer first. The new CNC machine will look pretty much like a box. The frame will be built using 3030 aluminum extrusion bars. Down here are the X and Y axis to move the platform. The Z axis will stay in place, just only moving up and down. All the plates and brackets are designed to be milled with the 3018 CNC. There are 3 plates like this one, and this one might be too big in size for the 3018 CNC to cut the outline, but all the holes and slots will fit inside the 3018 CNC working area. And I will show you in details how to make this biggest plate. The rest of the plates and brackets are really easy. I won't go into details of the process. To make the frame more sturdy, I will use 3/4 of an inch thick plywood. The linear rails are SBR 20 or SBR 16. I have SBR 20 for the Y and Z axis. I bought the SBR 16 for the X axis by mistake, but that wouldn't be fine. You can replace them with SBR 20 if you like. All the end bearing mounting plates like this and this are designed to give you plenty of room to use either SBR 20 or SBR 16s, and the same flexibility will be applied also to the bolt screw. I have the SFU 1204 on the X and Y axis and the SFU 1605 on the Z axis. The reason that I have the 1605 on the Z axis because I already have one in my stock. One thing to remember is that all the bolt screws are end machined. The overall length should be 50 mm longer compared to the rails. For example, here on the X and Y axis, I have the rail of 500 mm length. The bolt screw should be 550 mm length. And with this design, I will have the working area about 30 by 30 cm and 15 cm on the Z axis. You can easily change the working range in any axis. Just remember, when you change the length of the rails and the bolt screw, you also should change the length of the aluminum extrusion in the corresponding axis. For the spindle of this first version, I will use the 52 mm diameter type because I already have one. Hopefully it can still cut the aluminum smoothly. And another reason is that I want to keep the cost of this machine low. The first version I estimate about $700, not $5,000 like these machines. They can only mill aluminum and have much smaller working area compared to my other machine. Right now I'm still waiting for all the materials to arrive, so I will show you first how I will mill the plywood parts. In Fusion 360, I will go to File, Open from my computer, go to the folder of the machine design, go into Step Files, Platform. I just go directly to Manufacturer, create a stock. This time I will choose the reference in the middle of the plate. And click OK. I will mill all the brackets and place out 3/4 of an inch thick plywood. I will go to 3D pocket clearing, select tool. I will choose my favorite tool is the 1/8 of an inch flat end mill, 12,000 RPM, cutting feed rate. For pocket clearing, I will leave it at 1000 mm per minute. I just leave all the parameters as I entered before. Machining boundary, selection, this boundary. It will mill all the holes inside the plate. 2, 5, bottom offset minus 0.7 mm. This is to make sure that the bit will plunge all the way through the plate. Tolerance, well, I will give it a bit more precise. Maximum roughing step down, I will go with 1.5 mm. Shock to leave, nothing. Full retraction, no. Shortest path. Okay. This one I will increase it a little bit, 3 degree. Ram clearance high, maybe I put 1 mm. Minimum ram diameter. Because those holes are pretty small, so I will put a lot smaller. I will put 0.5 mm and click OK. As you can see here that all the holes are milled through, so that's what I want. And that's it, I'm done setting up the tool path for this plate. Very easy. So just right click, post process. New ultimate CNC machine. Name the file. Well, I will create another folder in here first. It will be platform. Toolpath number 1, 3.175 mm flat end, and post. And the platform cut to size here, 30 by 30 centimeter. Now I will have to find the center of this plate. It's very easy. I just take a long ruler and draw 2 diagonal lines. And here is the center. I will do the same to find the center of this platform. And this is the center. Next step, I will try to center the bit to this center of the platform and then set X and Y to 0. Just about like this, you don't need to be very precise. I have some pieces of plywood 1/8 of an inch thick. I will use them to space between the stock and the platform so the bit doesn't cut into the platform. At the four corners like this, I will use double side tape to tape them down. Okay, I take the platform like this. One thing I should do first before fixing this stock on the platform is changing the bit. This is 1/8 of an inch flat end mill bit. The flute length is 25 mm, so it will be more than enough. Now I will have to find a way to fix this piece on the platform. I will start by putting some of the double side tape on this wooden piece first. Now I will try to align the center of this piece to the bit. Press the corners down. It is pretty sturdy, but I don't think that it will be enough, so I will have to find a way to reinforce this. What I was thinking about is to cut some piece of angle aluminum like this, 90 degree. This side I had to cut it a bit shorter, so it can fit on the side like this, and slide inside the platform like this. I will drill a hole here and thread it with M6 tab. This one I will drill a hole around here to make sure that when I tighten the bolt will press right in the middle of this piece of plywood. The hole should be around here, probably 20 mm or 25 mm from this edge. for the Z0 because I don't have much space, so I just eyeballing here. Before start milling, I will move the X and Y axis back and forth to make sure that the spindle can cover the whole cutting area. Lucky that I checked because somehow the center of this platform is not center of the machine, so I will have to shift this platform a little bit. That's it, now I can start cutting. And that's it, this plate will melt exactly as I wanted. For these smaller pieces, the only thing different is just you can add a 2D contour to cut the pieces out of the stock. That way they will look better and more square compared to cutting with the saw. 2D contour, still the same, but you have to reduce the cutting feed rate. I will go with 300. 300 plunge rate. I will go with 100. Contour selection, this one and this one. Tap, yes. Tap high, I will increase it a little bit. 2.7 millimeter. Tap distance, I will increase it so I have less tab, like this. Multi-def, just go very slow. Let's say 1.5 millimeter. Yeah, we have to reduce this and click OK. And that's it. Everything look good. I will use these two paths to cut. Not too bad. I think the top will need to be a bit thicker because the pieces get loose. But it will cut all the way through. The edges are smooth, so I think that's good. I will continue to do this for a few more days. Here are all the pieces that I need following my design. I hope that I didn't make any mistake because it took me 2 weeks to mill all this, and I am kind of sick with the setting up the milling on the 3018 CNC. I really need to take a break from that machine right now, but for now the most tedious step is done. Let's move on to the next one. From my estimation, I will need about 16 or 17 aluminum extrusion bar like this, 3030 series, 1 meter length. So I bought 20 of them and they cost me $200. Now I will have to trim them to length. I will include the list of lengths that I need and also how many pieces that you need. You don't need to trim those bars to the exact length, but try to be as close as possible. The most important thing is that each set of bars should have the same length, And to trim them to that requirement, I will use the same trick that I show in many videos. I will use the M8 tab, make the thread at the end of all the bars. Use this type of plate to attach them together at the both ends so they will be aligned and they don't move when I cut. Using this plate I can attach maximum 8 bars together, but you don't need to attach all of the 8 bars. You can attach as many as you want. For example, I will need 6 bars 750mm length, so I will only use 6 slots. To attach the bars to the bracket, I will use M8 bolt, 30mm length, 13mm hex socket. Now I have all the bars attached together. I measure and mark the length. Adjust the blade and clamp the bars down. As you can see that cutting all the bars to the same length is really easy. I will make the thread on this end of the bars too. That will make the assembly of the machine a lot easier. I have all the aluminum bar cut here, so I am ready to assemble the machine. There are 2 axis blocks. The X-axis and the Z-axis can be assembled without being attached to the frame of the machine. I will start with the Z-axis block. I take the 4 bars of 330mm length. I will attach the end together. I take the 2 linear rails SBR20 300mm length. Place them on like this. I will use M6 10mm length to attach the linear rails to the bars. Drop in T-nuts M6. Place the rail on the bars like this. Do the same thing on this one. The way I wanted to install the rails on the bars is that this rail will stick out about 13mm from this edge of the bars. So I take one of these bars, place it underneath, and push the rail to the edge of this bar. Roughly, you don't need to be precise. Now I can tighten the bolt. Now I just slide on the linear bearing blocks. Take the Z-axis gantry block. This side is to attach the spindle. It should go this way where the rails stick out. Place this one on like this. I just need to bolt it down. I will use some M6 20mm length. Now this plate will be the reference to keep the distance between the two rails. Now I will take one of the 210mm length bar, place it like this. At the end of this bar, I will use some of the square bracket to attach this bar to those bars. Next step, I will attach this bolt screw set on this plate. I will have to use this piece as spacer, like this. Place this underneath. And use some of the M5 bolt 28mm length to attach the bolt screw to the plate. Remember that this BK12 block is on this side. Now I will attach this coupler to the bolt screw. Next step, before attaching this block to this plate, I will attach the stepper motor to this plate first. I have 4 of the M5 60mm length. I will have to attach the motor on like this. I will try it on like this. Slide it in. Push it all the way in. Measure the distance here. Okay. It is about 22mm. Maybe I keep at 23 or 24 will be safe. I will use a lot of M6 nuts as spacers. I will need about 5 of them on each of the bolt. I don't think I will need the bolts this long. Put on the nuts. I will take some of the M6 bolt about 25mm length. Slide them through here. Put on the T-nut. Now I will try to slide the shaft of the motor into the coupler. Press this block all the way to the plate. Take 2 of the long M5 bolts. Just slide through the hole here. Tighten with the nuts. Tighten the set screw on the coupler. Then turn this around. Before attaching this piece to this block, I slide some of the M6 bolts through. Put on the drop-in T-nut. Now I can slide this plate on the 4 bolts. And I just need 4 nuts to tighten the bolt. And now I will flip this block over. Take this ball of 90mm. Slide it in here. Okay, press this against this. I will use 2 of the square block. Fix this bar like this. And that's it, I'm done with the Z-axis block. It is very sturdy and everything can move very smoothly. I cut a code for the whole last week, so I couldn't do much. The only thing I did is that I add 2 of these blocks here to increase the support on this bar, and that's it. Now I can put this Z-axis block on the side and continue with the X-axis block. I take 4 bars of 500mm length. As I said before, for the X-axis I will use SBR 16 500mm length. But to make it less confusing in the design that I share, I will only use SBR 20. Actually, before installing this rail on those bars, I think it's better to use some of the square block to attach the bar together first. Now you can fix the rails on the bars. I will do the same thing for this side. I just slide on the linear bearing blocks. I will have to attach these two plates on those blocks. I will use 16 of those M5 40mm length. It slides really smoothly, a little bit different from the Z-axis. To fix this 210mm bar at this end, I will use this type of corner bracket that I bought on Amazon, like this. The reason is that I don't have any space up here to use the square bracket. And now I flip it over. Now I can reinforce these corners with the square brackets. All the next steps are very similar to the Z-axis block, so I just skip very quickly. And that's it, I have the X-axis block done. Now it's time to clear up the table, prepare the space for the Y-axis along with the base of the frame. For the base of the frame, you will need 2 of these long bar, 750mm length, and 6 of the bar with the same length, 500mm. The base of the frame will look like this. These bars here will be used to install the linear rails. This to fix the side of the frame. So let's just put everything together. I will start by install the linear rails on the bars first. Now I take these 4 of the 90-degree corner bracket. The 4 brackets have the big hole in the corner here, is to slide the M8 bolts through. These 4 corner brackets will be attached at the corner like this. The M8 bolt here is to attach to the end of this bar. Now I have this rectangle base attached together. Just put the rails in here. From my design on the computer, I measure the distance from this edge to this edge is 219 millimeter. I take this ruler, put 219 millimeter. And again, I'm going to use some of this corner bracket to fix this bar together first. I can take the bracket off later, but for now I just want to make sure that the bars won't move. And I will leave this side loose for now so it can move around. Slide on the linear bearing blocks. Take these two plates. Move this bar. I made a mistake. The distance 219 millimeter is not from this edge to here. It's from the inner edge here to this edge. So I will have to loosen those brackets. Now I can install the plate on. I will use 16 of the M620 millimeter lengths to fit this plate to the bearing blocks. I made a mistake here. This plate should be installed like this, parallel to the bars. Now I will use some of the M6 ball 25 millimeter length. Slide on the washer. Slide through the hose from underneath. Put on the drop-in T-nut. Now I think just I will let it loose on the side. Put this frame up here. I take the x-axis, put it on the table like this. This plate is supposed to be installed on like this. I will move the bracket closer to the edge here. Again, from my design, I measure the distance from this edge of the bracket to the inner edge of the aluminum extrusion bar is 110 millimeter. I actually will have to uninstall the brackets. After measuring, I will fix this bracket down. Now I will use this square bracket to fix this bar to the frame. Make sure that the y-axis moves smoothly and fix also this side. Now you have those square bracket on, you can take off those side brackets. Next step, I take this corner bracket to reinforce the corner of the frame. I will also reinforce the bar with 2 square brackets. Next step is to install this ball screw on the y-axis, but before doing that, I will attach this 130mm length bar. I will use 2 of the square brackets to do that. Now I take this plate and the spacer, attach this plate on like this. I will use 4 of the M5 28mm length. This plate here will be fixed right here, so I will slide some of the M6 bolts through with the drop-in T-nut. Roughly adjust this to the middle here of the 2 brackets and tighten the bolt. I will take 4 of the M5 bolts, 40 or 45mm length, slide through here. Now I take this plate, slide through some of the M6 bolt. I just slide this plate on here and tighten with the nut. Actually, I should turn this block around and slide this plate on this way. I will leave this side like this for now. From here, things get pretty similar to the X and Z axis. Now this end is fixed, I can fix the other end. This is not easy, so I think that I can think of other way to fix this. Okay, what I will do is that I will slide the bolt on this plate first and attach on the block from this side. So that way I will have more space back here. Now I can use the bolt again. Slide this bar on. I just realized why I made the design like that before. Because if I do it this way, I cannot really attach this bar to those bars using the square bracket. It gets blocked by this bracket. So I have to think of the way to shift the bracket a bit on the side. I think that I will use the bracket to fix the inner corner here. I'm almost there, but this bar a bit too long. It gets blocked by the bolt, so I will have to trim it. So this bar now is about 118mm length. And you can slide in here. So I'm just going to fix it on like this. And that's it, I'm done with the base of the frame and the X and Y axis. Now I will flip this over. It is heavy, so make sure that you have everything clear out before you flip it. Wow, like this, it's not bad at all. It's very sturdy. Next step, I just build up the frame to attach the Z-axis to it. I will need another 4 bars of 500mm length. Attach this bar vertically to the corner bracket. I will take 4 more of the corner bracket to reinforce the bar like this. I take 2 bars of 560mm, place them on top like this, and fix the bar together using some of the corner bracket. Next step, I will use the T bracket to install the bar on like this. From my design on the computer, the distance from this edge to this edge is about 280mm. So I set the distance and measure and tap it down. It is very sturdy, but I wanted to make sure that it wouldn't move, so I will use some of the corner bracket to support inside of the corner here. Next step is to install those 2 bars, 750mm length, one like this and one like this. For this bar up here, the distance from the back here to this edge is 118mm. For this bar, you just add 13mm more, so 148mm. I will use the corner bracket to fix the bar on like this. The next step is to attach the Z-axis block on this frame. It will be attaching on like this. So from my design on the computer, the distance from this edge to this edge is 269mm. So let me just attach this bar to this bar first. At first I was thinking to use the bracket to attach this bar to this bar like this, but the distance from this hole to this edge is not exactly 15mm as I expected, so I couldn't do that. So I had to figure out another way to fix this bar to this bar. I have this extra piece of aluminum extrusion bar. I will install them on like this and install the bracket like this. That way this side of the Z-axis block will be supported by the frame. I intend to install more of the bracket here and here, also inside here, to increase the support, but I ran out of drop-in T-nuts, so I'm buying some more, and also I don't have enough of the drop-in T-nuts to install the bar here and cross here. to increase the sturdiness of the frame. But for the first version to mill aluminum, I think this could be more than enough. So I will continue to the next step is to install the spindle, connect all the wire to the controller board, and try to test milling some aluminum. To install the spindle, I use 4 of the M6 ball 80mm length. Put on some washer and slide them from the back to the front. Slide on the spindle clamp. Put on the washer and put on the nut. You can tighten this side first. Slide the spindle in. For the control unit, I go very simple. I have here 36-volt power supply to power the stepper motor drivers. I have 48-volt to power the spindle that I will turn on and off through this relay. And the control signal will go from the output number 1 from the controller board. This is the stepper motor driver for the Z-axis, X-axis, Y-axis. This is the DC step down that I step down from 36-volt to 12-volt to power up this controller board. I use this board because it's really cheap and it's compatible with Max 3. You can use any controller you like, Gerbo, another Max 3, Max 4, it doesn't really matter. But for me, this is really cost effective, and also I already paid for Max 3, so I just going to use it. Now I will connect all the components to this board, stepper motors, spindle, and that's it. The machine should be ready to go. I decided to hang the control unit on the side of the machine so it is more neat and tidy. You don't really need too much of cable management. There are very few cables that are actually moving, like this wire here for the spindle, and also this cable for the stepper motor on the X-axis. All the other wires will stay in place. Now I will connect the machine to the computer and test moving all the axes. Let's start with the Z-axis. Up, down, now to the X-axis. Move to the left, move to the right, okay. Y-axis, move to the back, move to the front, back to the center. The direction of the X and Y axis might be confusing on this machine. On the X axis, when I said moving to the left, but the platform moved to the right, it actually was the right direction, because what you were supposed to look at is the direction of the movement of the spindle compared to the platform. So when the platform moving to the right, the spindle actually moving to the left in reference of the bed, and the same thing with the Y axis. Now I will try to turn on the spindle with the relay. It worked, as you can see, so the machine is ready for milling. One thing I just realized that I forgot to install the stopper for all the axes. So right now, with the length of the ball screw, the bearing blocks might run over the edge of the linear rails. To stop that from happening, I will have to install some stoppers. For this side of the X-axis, I will use this plate that I used to align the end of the aluminum extrusion bar. I will trim it a little bit and attach it to the end of this bar. You will only need to install stoppers on one side of each axis. For this side of the X-axis, I will cut this square bracket by half and install it right here. Same with the Y-axis. The Z-axis, for the lower limit, I will just install one of the square bracket like this. For the top here, I will also cut this bracket by half and install it right here. So let me just do that very quickly. Now all the axes will stay in their limit. I will try to design a wasteboard and install it on this machine. That's all a bit rough. I think I pushed too hard on this long bit. Now I have the washboard installed. I can lower these two bars, so lower the Z-axis to use the shorter bit. Then I will do some calibration. I'm not going to show how I do it. If you want to know, you can look at my other videos. And then I will be ready to mill some aluminum. I just did the calibration very quickly on this machine, and this was really easy. I probably will show you all the trick in the next video. For now, I just wanted to test milling some aluminum on this machine just to see how it works. I'm pretty sure that this machine can do it because I used 200 watt spindle on the 3018 CNC, and I was able to do it roughly. On this machine I have 400 watt spindle, better frame, a lot more sturdy, so it should cut a lot more smoothly. I will try to make some square bracket out of this piece of aluminum sheet, 1/8 of an inch thick. I will use 4mm flat end mill single flute. I will cut a lot faster compared to the 3018 CNC. 1.5mm step down and 750mm per minute feed rate for pocket clearing. 0.8mm step down, 215mm feed rate for 2D contour to cut the pieces out. The 2D contour, I couldn't do it directly on the 3018 CNC, but with this machine I think it will be able to handle it, so let's see how it goes. From my experience with milling aluminum sheet, it is good to clamp the stock down, but it is also very important to clamp all the sides to make sure that it doesn't rotate or slide when you cut the 2D contour, because the loading on the 2D contour is very strong. It might push the piece out of place, so then make sure that you have a good clamp or vise system to push the piece from the side. I think it will be enough like this. And one thing that I haven't mentioned, that I will cut just like this without any compressed air or coolant to spray on the bit, just because I haven't installed the system yet. Get ready to see some smooth cutting, hopefully. It took 1 hour 15 minutes to cut 9 of this square bracket. Let me just take them out and show you the quality. As you can see that all the pieces were cut nicely. All the paths and holes were cut through. All the tabs are in place to keep the pieces on the stock. Let me just take one piece out to show you the edges. The outline edges are not as smooth as I have on the 2.2 kilowatt spindle. I think that 0.8mm step down for the 2D contour is a bit too much. Maybe I will reduce it to 0.5mm. It will cut a lot smoother. The inner edge of the holes here are really smooth because I did a finishing pass for each hole. So it is really smooth and shiny inside. In overall, I think the cut was quite smooth. It is the best cut that I have on the 400 watt spindle. And to make 9 brackets like this out of aluminum is a lot faster compared to making them out of plywood on the 3018 CNC. So I think that to upgrade this machine to all aluminum bracket would be a lot faster compared to the first step building this machine out of plywood, and the machine would be a lot more sturdy. At the beginning I thought that I will show you how I will replace all the bracket with aluminum pieces, but the video is taking a lot longer than I thought. So I think that right now is going to be enough for this video. I will show you the next step to upgrade this machine to all metal brackets in the next video. If that doesn't take too long, I will also show you how I'm going to upgrade the spindle to mill steel. I hope that you also like this design. You can build this machine just use your 3018 CNC, and the biggest power tool you will need is the miter saw. So it really doesn't require too many tools and equipment to build this machine. You can cut aluminum pretty smoothly with this 400 watt spindle. Imagine if you have bigger spindle like 1.5 kilowatt or 2.2 kilowatt like I have on the other machine, it will cut so much smoother. And also I'm sure that after the next step, when all the bracket and plate will be made out of aluminum, it will cut so much more precisely. So stay tuned for